that my title is not that. I have also made the committee that my title is hydrogel based adsorbent for removal of emerging pollutants from aqueous media.
Mhm. Can
Yes, sir.
you
You can check on the word file. I think they have sent me on the other day.
can you show the presentation?
Yes. Is the screen visible, sir?
It's okay.
Yes, sir. Is the screen visible?
Yeah, yeah, good. You can start.
Yeah,
Please.
yeah. Yes. First of all, I thank you, the committee members, for giving me this opportunity for to represent my review paper, that is hydrogel-based adsorbent for the removal of emerging pollutants from aqueous media. And I thank my guide professor HAG, Dr. Balbir Singh Kaid, for giving me this opportunity. And in this context, we will look about the introduction of what is the water pollution exactly, and what we are going to remove from it. And again, then it is hydrogel and the classification of. Then we move towards the classification of hydrogel and characterization and process governing adsorption, uh, kinetics adsorption model and thermodynamic studies, and conclusion, and what are the future perspective about that. And this review paper is based on the what recent advances have done in the previous in between 2015 and 2025 research paper, that how hydrogel has manipulated using nanoparticles or some other materials. So first of all, that introduction, that uh, what is water pollution exactly that we are looking for, like it is a major environmental problem, that in which there are many uncontrolled release of pharmaceuticals, dyes, pesticides, and personal care products, and they are carcinogenic, which is can be dangerous to our health. And these all groups are as emerging pollutants, and they affect our health. And for that, the basic part of that is our body is 80% water, and it affects our human health. And that impact of poor drinking quality can result into waterborne disease. And what WHO said this about that, that 80% of world's diseases are linked to poor drinking water quality, and 50% of child deaths globally are due to unsafe drinking water. So over 50 diseases are caused by poor drinking water quality. So situation in developing countries are like that. The quantity of water drinking in developing countries is a major concern, which leading the mortality and morbidity in these region. And these are specific causes that can be caused from the pollutants, which are dyes and different pharmaceutical products, heavy metal ions, which are carcinogenic, that help affect our health, that is called diarrhea, skin disease, cancer, and child health issues. And so what we are looking for to counter that, so we can't, so in this review we are not talking about the microbes and the viruses, mostly that the pollutants, dyes and dyes and all. So first of all is the sustainability and green approaches, and the cost effective and biodegradable. What we are whatever we are synthesizing, it should be biodegradable, and do not harm any do not harm the environment after degradation. And it should be cost effective if we are commercializing it. and the process of synthesis should be green, uh, to like maintain the like green chemistry and the sustainability, that whatever we are synthesizing, uh, it should it should be used up to 10 to 15 cycle times, and more than that. So conventional methods often are like ineffective, eliminating these contaminants from water resources. So what we are looking for is the hydrogel, that what are the hydrogels, and this has a high affinity to absorb the water more than its capacity, and it has emerged as a good absorption material over the past few decades. So in the next slide, I'll talk about the what is hydrogel. And the hydrogel are the 3D dimensional network of hydrophilic polymers that can swell in water, and it swells due to various hydrophilic groups, that is OH, CONH, or CONH2, and further there are many groups that can participate in making it hydrophilic, and it absorbs mostly 80-90% of its capacity. And the main important thing is that do not dissolve in water due to its cross-link structure, which is mainly come from the cross-linking, by cross-linking it or polymerizing it. So again, next is the classification of hydrogel, that based on the biodegradability, source, charges, and types of cross-linking. So there are four, but there are many, but like I'm representing only four here. First of all, that is source, based on natural and synthetic, in which natural based are which are extracted from animal and plant extract, in the chitosan, sodium alginate, cellulose, and hyaluronic acid. Most of the like presentation is based on chitosan in the conference. These application can be wound healing, in the tissue engineering and the drug delivery, and these are biocompatible and biodegradable materials. And the second one is synthetic, which which are lab materials, uh, synthesized like PEG, PVA, PEA, which can be used as the super absorbent polymer, contact lenses, and biosensors. Now the second one is type of based on the type of cross-linking, mainly of the two, chemical cross-link and physical cross-link, in which chemical there is an interaction which are uh, irreversible in nature, and they are stronger, they have stronger interaction than the physical, like chemical bond, bypass stacking, and all. Examples are cellulose, glutaraldehyde, and formaldehyde, and etc. These application are biomedical scaffold, uh, in the treatment of osteosarcoma, mostly the uh, bone cancer. We are now making a scaffold from the polymer, and if it's used as a scaffold in the cancer treatment, why not it is in the drug delivery system. So again, another is physical crossing. uh, Mainly it is irreversible in nature, and the type of interaction is mainly H bonding and weak van der Waals forces, and these are some example: PLA, PVA, and HA. And the applications are injectable hydrogel, pH or temperature sensitive systems. Now, based on the electric charge, ionic, non-ionic, and ampholytic. In ionic, there are two categories: cationic and anionic. Cationic, which carries the positive charge, and anionic, which the uh, with the hydrogel, which carries negative charge. And these are the examples in which these due to this conjugation, they act as a negative charge. And the application, the dye absorption, gene delivery, and absorption of anionic and ionic contaminants from the wastewater purification, because of dyes and dyes and heavy metal signs are the positive and negative charge, and according to that we can take our paste hydrogel, whether it is cationic or anionic or a non-ionic, which do not carry any charge, like PPA, PEG, PA, and PHEMA, PHEMA. So, sorry. And the application must here in the drug delivery, where charge interface must be avoided. And the ampholytics, which contain both positive and negative charges like polybutanes, lecithin, and the application are in the antifouling coatings and the blood contacting devices. Now the last one is based on biodegradability. First one is biodegradable and non-biodegradable. First, the biodegradable is like uh, which can be consumed through microorganism and through which do not uh, result any harm to the environment. For instance, PCL and polybutamino ester, PHBV, and mostly if they are biodegradable, they use in the drug, drug delivery and environment friendly materials and temporary implants that because of biodegradability. And second one is non-biodegradable, which uh, do not consumed with the time from environment itself. That is PBA, PA, and mostly non-biodegradables are also the synthetic one. And application are long-term biomedical devices, contact lens, and synthetic gel. Both synthetic and non-biodegradable are similar to their properties. And now the properties of hydrogel, that these are biocompatible. Biocompatible means it do not react with our blood and mechanical properties, which can be enhanced by several cross-linking and polymerization. And as a we can use it as a scaffold, which enhances mechanical property. And the swelling property, as I said earlier, that it holds more than its capacity, over 80 to 90%. And stimuli responsive properties, that according to pH, temperature, and other means, they are responsive to that property. And application are in various field: agriculture, biomedical, cosmetics, environmental application, where our focus is, and food industry, and the soft robotics. In the agriculture, mostly that control release drug, that uh, first they absorb fertilizer and they release controlled. And in the biomedical application and all other applications are as follows, that I also include in the types of hydrogel. And now the characterization of hydrogel involves FTIR, DLS, TAM, TJDSC, and XRD, and the SAM TAM are quite similar, that it explain the morphology, topology of the system, but SAM provides the 2D image of the system, of the material. Sorry, 3D material of the 3D image of the system, and TAM provides the 2D image of the system. But in the TAM, that material is encapsulated with the nano materials. TAM resolution quality is higher than SAM. Uh, uh, the next one is FTIR, like whatever we are fabricating from cross-linker monomer, then it provides the functional group of the material. And the DLS is it is related to nanopolymer. The range of it describes the range of nanopolymer, that it is ideal or not. Mainly the ideal nano size range is less than 100 nanometer. And the PXRD about the crystallinity and amorph, whether it is amorphous or whether it is crystalline. That most of our polymer are crystalline, and it can show the peak like this. But if it is graphene oxide nanomaterial, it shows some peak like that. That's the reference. And the TJ and DSA analysis mainly focus on the thermal stability by comparing it with the uh, um, percentage decrease in weight with respect to temperature, or the heat with respect to temperature. And these are the characterization which involve the hydrogel. But there are some other uh, characterization that involves that NMR and all other things. If we are like uh, synthesizing the monomer from organic synthesis, we can use that in the process. Now the process governing adsorption in hydrogel systems, that uh, within that mostly there are three type of adsorption: physical, chemical, and diffusion mechanism. Like physical, in which there is a less weak bond like H bonding and water wall interaction, and the chemical adsorption involves chelation, ion exchange, and there are some kind of electrostatic interaction and pi stacking. Pi stacking mostly involves the aromatic rings, and these hydrogel and their renewable structure uh, functional group enable selective adsorption through ion exchange, hydrogel bonding, and pi interaction. Additionally, their biocompatibility and reusability make them ideal for sustainable purification. And here is the like kind of a reference from a paper that is from the Kiwang, that is removal of anionic dye from aqueous media by using a novel high charge positively charged hydrogel with capacity. That it has also shown the beautiful adsorption mechanism, that this dye is uh, showing the different interaction, that by stacking and H bonding and kind of wonderful interaction also. Now the as the adsorption mechanism is done, we will move how they if, we have to confirm uh, that this dye is actually absorbing something, but it is physical, but we need to make it happen through calculation, and then these models comes, kinetic and isotherm model. We will particularly focus on the pseudo first order, second order, and intraparticle diffusion. And second one is isotherm model, which is Langmuir, Freundlich, Tamkin, and Evolich model, which help evaluate surface heterogeneity and adsorption capacity. First one is pseudo first order model, which uh, gives the rate of occupation of adsorption site, which is proportional to number of unoccupied sites, often indicating the specific chemical reaction. And this is the uh, chemical equation, that is log QE minus QT is equal to log QE minus K1.2.303T, in which Q is adsorbate, Q is equilibrium absorption capacity, and Q2 is absorption capacity at particular time, whether we are like in the series of time, like 10, 20, 30, 50, whatever the minutes in which you are die or heavy metal ions is absorbing. And the K1 is rate constant for pseudo first order model. And the second order model, like it suggests that whether our adsorption is chemical or not, involving valence force through sharing or exchange of electron. And this is the chemical equation: T by Q T is equal to 1 upon K2 QE square plus T by QE, where K2 is the rate adsorption constant for pseudo second order model. And third one is intraparticular diffusion model. Uh, that is account for diffusion of adsorbate within the pores of hydrogel, which can be controlled step in adsorption process. And this is the equation, and these are the graph that is taken from the paper. That first one is for the first pseudo first order model, and second one is second order, and third one is the intraparticle diffusion model plot. And the second model is the isotherm model, which uh, explain us the adsorbate and adsorbent interaction at constant temperature. That first one is Langmuir isotherm, which mainly suggests that it is a monolayer adsorption, that adsorbent has finitely adsorb in the adsorbate. That is which is here is the common uh, chemical equation for the Langmuir isotherm, in which Q is the adsorption capacity, Qm is the maximum adsorption capacity, where Q is for the equilibrium, and C is the equilibrium concentration, and B is the Langmuir constant. And we also look for the RL. after calculating these stuff, that these values should lie in between 0 to 1, which shows the favorability of this isotherm. And this is the chemical equation for that. RL is equal to 1 upon B plus 1 plus B C naught. And a fluid isotherm which focuses on the heterogeneous space and multi-layer absorption. That is, can be also called as the physical physics option. That is also multi-layer absorption, but in the laminar, it is a monolayer, and we can call it as a also call it as Cam's option. And the Temkin model, which it it just suggests the adsorbate and adsorbent interaction, that it is proper or not, and this is the chemical equation. And the Evolich isotherm that is useful for that, where adsorption site increase exponential with adsorption, and here is the chemical reaction in which suggests that Evolich isotherm. And these are this is the how we can interpret it, the data for Temkin and Evolich isotherm. And the another one is thermodynamic studies, in which we find the parameters such as delta G, that is Gibbs free energy, and delta H, molar enthalpy, and delta S, which is entropy, in which delta G is should be negative for the spontaneous adsorption, uh, and delta H can be positive or negative, whether it is exothermic or endothermic reaction, based on the interaction between them. And delta S reflects the randomness between the solid liquid surface. And this is the equation for that. That is ln case is equal to S upon R minus H naught upon RT, which is in which Kc is adsorption constant and R is universal gas constant, in which and these are the free energy. And this is the Van Hoff equation in which we interpret the data for that. And for the conclusion and the future work, prioritize that hydrogel-based adsorbent are increasingly recognized as sustainable and versatile material for addressing emerging water pollutants. And the development of multifunctional hydrogel is directed toward tackling multiple pollutants simultaneously, making them highly adaptable for diverse water contamination scenario. Means key features are that whatever we are synthesizing, it should have high absorption capacity, and it should be selective toward whatever we are going to target. These two are same, and this is a recyclable material. And whatever we are synthesizing, it should have some reusability, up to 10 5 10 or 15 times. Then it is ideal material for to tackle water pollution, uh, mainly the contaminants from it. And the future application can be the advanced wastewater treatment, heavy metal ion removal, and and also the emerging contaminants mitigation. And these are the conclusion and the future perspective of these presentation. And thank you. I also I'm thankful to the committee members and also my supervisor, Dr. Professor B.S. Kayat, for giving me this stage for presenting something in this conference. And I'm grateful for the opportunities, if it's whether my college, that is NIT Jalandhar, and whether my professor, and also the conference committee members.